Okay, so very quickly, first thing, let me just check if everybody can hear my voice and if you can also see my screen. On the screen, I have displayed at this moment the syllabus, what we'll be covering in this complete training. So I just want to get a heads up on if you can see my screen and if you can hear my voice. Okay, so I can see that people can hear my screen and sorry, see my screen and hear my voice, right? Let us get started. So first thing, welcome to this training. This training is going to happen every Saturday and Sunday, like how we did for Azure. The same way we will continue this training for coming 2 or 3 months, depending on how the participation from the students is. Very quickly, in this training, we will be covering the basics first. So like today, Saturday and Sunday tomorrow, we'll cover the fundamentals. Then we will start with different design patterns, which are related to GOF, which are related to non-GOF, which are related to microservices, and which are also related to cloud. So this time, I'm also planning to add more microservices pattern and more cloud patterns as well, right? Right. So first thing, if you have any questions, anything, please go ahead and put down on the chat, right? And any queries, right? I will try to answer in the last 15 minutes, right? So guys, let us get started out here. Now, before we start with design pattern or architecture patterns or anything, right? The first thing, which I want to, the first 5 minutes, I want to talk a little bit of the, how do you say, the philosophy of architecting. The philosophy of architecting, 5-10 minutes. And then what we'll do is we'll cover object-oriented programming, just the basics part, the solid principles, and then we will start with design patterns and architecture patterns, right? Now, why it is important to understand this philosophy of architecting, right? When we talk about humans, right? If you tell to any developer who is also a human, definitely, that go and understand this complex system. If you give any complex system to a human, right? The way humans understand complex system is by classification. I'm repeating this. If you give any complex system to a human to understand, for example, I put down some print screens out here. Let me just show you. For example, if you tell a human that, okay, go ahead and understand that what are the different species in our ecosystem, right? What humans have done is, they have started classifying, saying that, okay, this is a mammal, this is an aquatic, this is this, this is this. By using classifications, human understand things better, right? So basically what happens is, like if you tell someone that, okay, can you tell me that this is aquatic or not? He will ask questions saying that, can he, can he go in water? Can he stay on the land? Does he have fins, right? And then he classifies that, it is aquatic or not, right? So the point what I'm trying to make here is that humans understand classifications. So when any architect, when he takes a complex system, any complex system out there, a financial system or a travel domain, right? The first thing, what he has to do is that he has to ensure that his classification is right. If his classification is not right, then everything goes wrong. This is the philosophy of architecting. I would suggest everyone to go and read the book of Eric Evans, which talks about the philosophy of architecting, the person who made DDT. Why am I talking about this is because if the classification goes wrong, if the families go wrong, if the inheritance goes wrong, everything goes wrong down below, right? Again, let me just stress out this small philosophy out here. This philosophy also you can understand in terms of steps. So in terms of steps, it goes like this, that anyone who is trying to understand a complex system, specifically human brains, right? It's a two-step process. They identify a thing. For example, if you say, okay, there is a fish or there is a snake or there is a lion, right? So he identifies that thing and then he classifies it. Now, when actually a developer or when an architect actually sees a requirement, right? What he does is actually he identifies the entity, sorry for my handwriting, right? And puts them into a classification, which we term it as abstraction. Abstraction, right? So now this identifying of the entity is done by the thing, what we all learn, which is object-oriented programming. So when you actually are given a requirement like this, just assuming you are given some kind of a requirement like this, let us say this requirement out here, as a human, what we do is that we say, okay, what are the nouns in this? What are the things in this? We say, okay, customer, products, discount, delivery, right? And then we start classifying them. For example, if you're given an example of a company, and if you say that, okay, there are employees, who are managers, who are team leads, who are engineers, you'll say, okay, whatever it is, you are at the end of the day, you have an employee classification, right? So the first thing, the two things, which should be very clear to be a good architect is that you should understand object-oriented programming. You should be able to understand how to identify an entity, and you should be able to think abstractly, think in a classified manner, right? So when we talk about object-oriented programming, that's what it helps us to do, is that it helps us to identify the entities. It helps us to say that, okay, here is an employee, here is a discount, here is the salary, here are the managers. So it actually helps you to identify the entities. And once those entities are identified, then you can start classifying them, right? So the first thing, what happens really in a person who's trying to do a proper architecture is that he has to ensure that his abstraction, his classification is right. Now, when you're doing this abstraction out here, now remember, abstraction is not abstract classes. Don't jump to that conclusion, right? It's such a wrong thinking. Abstraction is just a thought process, where you say that, okay, this is an entity, and what are the important things needed for the entity, right? So for example, now look at this requirement out here. Okay. In this requirement, I've taken up a small requirement out here, and we will go ahead architecting the whole thing around it. Let's say we want to create a customer management system, and this system should be able to maintain customer data with the name, with the age, with the geography. We can have different types of customer who pays the money, customer who just does the inquiry. We can have different calculations for a customer, or discount calculations for a customer, saying that a normal customer will not have any discounts. Let us say age-wise, you will get some discount. If you're buying on weekends, you will get some discounts, right? And then you actually deliver, you have a delivery mechanism for the customer, right? So now let us say you get a requirement like this. The first thing what you will do is that you will think about, the entities. Remember I said humans understand by identifying the things, identifying the entity and classifying it, right? So you'll say, okay, there is a customer. Now there can be different types of customer, a normal customer, a customer who gets a 10% discount, or customer who gets a discount, depending on geography, whatever it is, right? We can just classify them into customer, right? So what, as a first thing, as a developer, you should be doing is thinking abstractly, abstraction. Normally, if somebody says that, okay, he tries to say a big story to you, so you can say him that, okay, can you first tell the abstract of this, the main gist of this, right? So first thing, as a developer, what you should be doing is you should be doing abstraction. Now, how do you do abstraction in your code? By using interfaces. So here it is. I'm going to go now. This is a very simple console application I have made here. And whenever I teach something, right, I will actually be creating a CS file out here. So for example, now because I'm teaching abstraction, I'm going to just go and say this is abstraction out here, right? So what you normally will do is, now many developers tend to write the classes first, which is okay, right? But when you actually try to write the class first, then you're not thinking abstractly. You already started thinking in detail. Abstraction means thinking from like 30,000 feet level, just from the top level, right? So by looking at this, right, we identify that there is one entity, which is interface, we'll say I customer, abstractly. Don't think about the details now. And you know what? Interfaces, the best part about interfaces is, why is interfaces very good in terms of thinking for abstraction, is because it normally does not have logic. I know that nowadays interfaces can have logic in .NET and many other languages as well, many other programming languages as well, but mostly interfaces are just empty methods, empty properties, just the shell of it. So that's why it is a very good place, to start thinking about abstraction. So I'll say, okay, there is I customer, customer will have products. So there are products. So I products, right? Product I'll just use. And then we said, okay, there's a discount calculation mechanism. Fine. I discount. Guys, any questions, please put out there, right? And so on. So you can see here at this moment, I'm just thinking from the 30,000 feet level that what I need, right? So now here again, if you look at the requirement, it says that a customer should have a name, it should have an age, and it should have discount calculation. Fine, right? So I'll say, okay, it has a name. Okay, let's put this. So name here. So you can see now, I don't want to write any kind of implementation internally at this moment. I just want to think that what is needed for this customer, right? And must be, we'll say that calculate discount. You can see now, this is abstraction, in the sense that I am not thinking internally what it has, right? I know that there is an entity. I have classified all my customer entity. Either they're having 10% discount, either they're having discount, either they're having no discounts, and so on, right? But I'm saying that I'm just putting them into one family, into one classification, I customer, right? So that is the first part, guys. If an abstraction goes wrong, everything goes wrong, right? So the first step when you talk about object-oriented programming is that just the planning phase, just the thinking phase, just thinking from a 30,000 feet level, the things what you want, right? Abstraction. Okay. Now, once you're done with the abstraction, definitely you have to start writing code for it, right? So we can see that this is the abstraction of I customer out here. We need to write the implementation behind it. Fine. So to write the implementation, I will now go and say implementation. Implementation means the actual code behind it, right? So I'll say, okay, this is I customer, and we want to calculate the discount. Let me also put here for now just decimal. And remember, guys, at this moment, I'm actually talking, I'm explaining, and then I'm writing the code. Normally, what happens is when you start architecting, right, you don't think too much. You read the requirement, you create the interface, you start writing the implementation, right? So it happens very quickly. Once you have experience, it is very quick, actually, right? But at this moment, I'm trying to go through that process, as slow as possible, right? So one of the things, one more property which I want to add here is that what is the amount of product he has bought. I'll just put amount for now. That this is a customer, this is a name, and this is the amount he has bought, right? And we have to calculate discount, right? So now you have the abstraction, and now you start writing the implementation. Normally, implementation will be written by the developers. Must be the abstraction would be thought by the architects, right? In smaller companies, I've seen that the same developer does it, right? So yeah, I'll say here this is implementation. This is the second phase which happens, implementation. So I'll say, okay, let us see here. So if you look at the requirement, let's go to the requirement. Guys, we're going to go and follow this as a project. The same project I will try to convert into microservices as well later on, right? So it's going to be a big, long journey out here. So I will say, okay, if you see this requirement, it has paid customers. It has customers who have done an inquiry. It has normal customers who do not have discounts. And some customers whose age, if the customer's age is above 60, he will get a 10% of discount and so on, right? So fine. So let me start with a normal customer. So I'll just say public class. I'll just write the word normal customer. A normal customer implements I customer. Remember, you have classified them into one family. You have classified them into one abstraction, right? And then you say, okay, implement it, right? So there it is, calculate discount and so on. Good. Then you see some other things out here. You'll say, okay, age above 60. Okay, so I know that at this moment I'm doing a very big architectural mistake out here. We will remove that architectural mistake later on. I can see that a lot of people already writing in the chat saying that remove the discount calculation out. I understand it, right? So let's say now another type of customer here is a customer who is a whose discount calculation is as per age. Okay, fine. So I'll say customer age type. Okay, and I implement I customer, and we do this. Nice, good. Okay. Now, when the developer is writing this implementation out here, right, he also needs some extra methods out here. For example, now he'll say, okay, this is calculate discount. I'm sorry for that. That should be calculate. I'll correct it. But before the calculate discount happens, right, the amount cannot be zero. The amount cannot be negative. So he wants to do some validations out here. So before even the discount calculation happens out here, he wants to say that, okay, how about going and checking the amount, is amount valid, right? What this amount valid does is it actually just checks, if this amount is, it should be greater than zero, right? It should not be negative and so on, right? So you just want to ensure that the amount is greater than zero and not like, so you'll just say true out here or else it's just false, right? So a small check you have put out here and there it is, right? So what happened now is, the developer out here says that before this calculate discount happens, right, we have to check if the amount is valid or not. If the amount is not valid, we don't go ahead with calculating the discount. Now that there are two steps out here in the abstraction. Whoever created the abstraction, either the architect or whoever, right, he said that, see, we just need to calculate discount. But the developer, when he went into the nitty-gritties, he said, no, I need some 3-4 methods extra out here. Now, what is happening out here is that the abstraction is saying, the abstraction does not say here, is amount valid, but the developer wants it. I'm repeating this sentence. The abstraction here, when the abstraction was created, when the 30,000 feet level was visualized, here, the architect did not think about this is amount valid because he said that this is the part of calculate discount, right? But now what has happened is, if somebody tries to use this normal customer, X is equal to new normal customer, if some client developer tries to use it, he will get everything. He will get a name. Yes, absolutely. This was needed. He will get an age. He will get a calculate discount. Why not, right? But he will also get is amount valid. Now this one here is looking uncomfortable, or is looking weird because this was not thought actually, right? So the point is that, here what is happening is in the encapsulation, the developer is making this as public. So what he should do is that, yes, he wants to go and use the is amount valid. He should try to respect the abstraction. So in other words, he has to now do encapsulation. To respect abstraction, developer has to do encapsulation. In other words, what he has to do is he has to make this as private. Whatever the abstraction defines, right? Whatever was defined in the interface, until needed, right? The developer should try to follow it, right? So in other words, when the calculate discount is called, right, at that moment, you should call the is amount valid. So if the amount is valid, then go ahead and do the calculation. So all this should be internal, right? It should not be like exposing out too many methods outside, right? So at this point, I'll just say return 0. So over here, if you see what is happening is, we'll look at this logic later on, right? Inside calculate discount itself, I'm calling the is amount valid, and he's making this as private. When you make this as private, you are actually doing encapsulation. You are hiding the complexity, right? So now what happens is, if you look at your customer, right, it is absolutely following the interface. It is absolutely following the abstraction. So you can see that this is the name, this is the calculate discount, this is the age. And when you call the calculate discount internally, the is check is called, right? So that's one part. Okay, let me too many calls here. Okay. So I'm just trying to put down a little bit of roadmap out here so that we are all in sync. So basically, first, we have the abstraction. Second, when we write the implementation for it, right? Or I will say rather, when we write the implementation, we actually follow encapsulation. Encapsulation respects abstraction. Remember, guys, all this process, which I'm now trying to show you through a magnifying glass, is all happening naturally. Please understand it, right? But it is very important to understand the nitty-gritty so that when you actually learn design pattern, right, it becomes very clear. What do you mean by abstraction? What do you mean by encapsulation, right? And remember that again, this encapsulation, when you look at programming languages like C# and Java, they have given different levels of encapsulation, so they say private and they say public and they say internal, you say protected, right? That is all there, but the point is that you have to use those access modifiers actually to do encapsulation, right? So first is we identify that entity, we identify the family, we do the classification. When we write the implementation of it, we ensure that we hide, whatever is unnecessary. And by doing so, we are actually respecting the abstraction, what was defined previously, right? So this is the second step. Guys, any questions, please put down on the chat and we'll try to think about it. So here now, very quickly. So just coming back here to the topic, abstraction is the planning phase. It is done by normally writing interfaces. To follow abstraction, right? So whenever you're writing implementation, you follow abstraction, or your implementation should follow abstraction by doing encapsulation. So by using the private, the public, protected, the whichever way you want your encapsulation to happen. Okay. Now, let's go back again here, right? Okay. So we are here. This is the I customer out here, right? Now, if you see here, what is happening out here is, okay. The another important thing, which in object-oriented programming, a lot of people fail to understand is the importance of polymorphism. If you see out here, we are actually into a classification. Our employee here, this employee out here, you have a normal customer, the customer, a customer age by type, and many other customers can be down below, right? So now, because you have abstraction at the top, right, you can use this beautiful feature of object-oriented programming, which is nothing but, your abstraction, where you can say now, my customer, can point, my interface can point towards a normal customer. My interface can point towards anything down below, customer which does, according to age, which does the calculation, right? This is the most important factor of object-oriented programming, because if you just think for a moment, right, at the back end, if you see, you have different types of customer, right? Polymorphism means on runtime, your customer can take shape of a normal customer. Your customer can take shape of an age type customer, or a weekend discount customer, or any kind of customer, right? In other words, when I look at this I customer, and when we use this polymorphism feature, polymorphism means, this poly means many, right? Your I customer out here is taking many shapes. Morphing means it is changing on runtime to a normal customer, to an age type customer, or whatever, right? So at the back end now, what happens is you can have any kind of customer, a normal customer, or a discounted customer, or must be an inquiry customer, or a customer who has not paid any money, a defaulted customer, and so on. But when a UI sees this, right, you only sees I customer. This is again very important feature of object-oriented programming, where polymorphism, by using polymorphism, you can achieve decoupling. You don't have to know what is there at the back. You will just look at I customer, right? In other sense, from this, because of this abstraction, actually, because you were thinking abstractly, right? You can now have this beautiful thing, polymorphism, right? By which, you don't have to know, which kind of class you are referring at the back end, right? So that is again another type, which is important. And remember, guys, when you're talking about, let me exit from everywhere, too many. So, and when you're talking about decoupling, right? Think about it for a moment. At this moment, you can see that I'm saying, okay, new normal customer, new customer age by type, right? But let us say that my client, this console application does not want to know what the type of customer is, right? So he can just stick like this. He can say that, I don't know what kind of customer will be at the back. I will just point towards I customer. So by having an interface at the top, by having an abstraction at the top, what happens is you don't have to know the backend changes what is happening, right? I'll come to that, the factory pattern and abstract factory pattern, right? But the point is, rather than dealing with the strong type classes now, you can refer a very generic interface over here and you can have proper decoupling, right? So that is again another feature of polymorphism out there. Okay. Now, the other thing, which is important out here is about the wrong classification. You can get into something called as a wrong classification, which is called as the Lisco problem. Okay. If the abstraction goes wrong, what will happen? Think about it. So for example, now look at this. Let us say, if you look at this requirement out here, there are two types of customer. One is a paid customer who have bought products, and another one is an inquiry customer who has not bought any products. Now, what you think as an architect is you think that, okay, this looks like a customer. Everything is a customer, right? So what you do out here is you go here and you put them into one classification. So you say, okay, everything is a customer. Even the person who does inquiry is a customer. Look at this. Inquiry customer. And you say he also belongs to I customer. No problem. Now, what happens when the developer starts writing the code for inquiry customer? He is confused. He's confused because when a customer who is doing an inquiry, right, normally there won't be any discount calculation for him. I repeat this. A wrong abstraction. When the abstraction goes wrong, and this is very but natural in a big project, when you're having 100-page of document, right, such kind of wrong abstractions can always happen, right? So what has happened now? You thought that normal customer by age discount calculation, customer weekend, and you also put inquiry customer into the same bucket. But now when the developer who's writing the code, he does not know what to do here. Now, the only thing, what remains for him is that he can either say return 0 very silently, right? Or either he can put a code like this, throw new not implemented exception. But there is no way he can subtract this method. He cannot subtract amount also, like amount for a customer who is doing inquiry, he's not buying anything. And there is an amount out here. This is a classic example of a wrong abstraction, right? So remember, guys, when we say abstraction, some abstractions are very easy, very but obvious. For example, you say that, okay, there is a customer and there is a discount, fine, or a product. This is understood, very easy. But now inside the customer, there are thin abstractions, which are very difficult to identify. For example, which I just showed out here, the inquiry customer. Now what to do over here? Because when you implement an interface, you have to implement all the methods, right? So if you don't implement them, you will get this error out here saying that no, this and this, right? So this is called as a Lisco problem. We will talk about solid principles, but I want to emphasize the importance of abstraction here. So I'm talking about Lisco. So if you look at Lisco, right, just to Google and just show you Lisco issue, Lisco substitution principle. The famous image of Lisco, if you go and see, this is the famous image of Lisco, the duck image out here. What happened out here is, it looks like a duck, it quacks like a duck, but one duck has a battery. So what Lisco principle says that something which was looking very, very similar, right, which were not similar, actually, you put them into one bucket. You probably did not understand the requirement. And that's where you made a mistake out there, right? So this is a very famous proverb of Lisco, which goes on the internet. It looks like a duck, it quacks like a duck, but so it looked like a customer, it had a name, it had an address, but damn, he does not buy anything. So that is not a customer, isn't it? So in other words, now to correct this issue, right, what you have to do out here is you have to make an abstraction, right? You have to say that there is I customer and there is I inquiry, right? So you can just say that interface I inquiry, you should have two different interfaces. This is where things have gone wrong. And for I inquiry, you will just have the name and the age, period. Now remember that at this moment, we identified the Lisco problem very easily. and we went at the top and we just broke the interface, right? But think about it, that if you're working in a big project and you carry forward this Lisco problem, let us say your development goes on for 5-6 months, and after that someone says, oh, we have a Lisco problem now, can you go at the top and just break them? It is calling for trouble, right? So Lisco problems are very difficult to identify, very difficult to even know. Like sometimes when you go down below, right, people just silently say return null and just or write something like this and just close it, right? But the proper way to close is that inquiry customer should implement an inquiry interface. Now this is clean. So actually they actually belong to two different family, I inquiry and I customer, right? So guys, when you're doing this classification, when you're doing this abstraction, right, just keep this Lisco problem somewhere in mind at the back, right? Or else what will happen is when the inheritance chain becomes too long, when the project, when you write a lot of code out there, it is very difficult to revert back and change from the top, right? So that is an important thing to understand. Okay, so let me draw the diagram ahead. So when you are doing this abstraction, it is possible that you can get into a Lisco issue, right? And to solve the Lisco issue, you have to break the interfaces. Out here, okay. Now, one more important point, which normally as a developer we should be knowing very in detail is inheritance, aggregation, composition, and association. Now I understand that inheritance many people know, right? But let's talk about this aggregation, composition, and association. Right? So very quickly first, so let's go back here. So now let us say you have this I customer out here, assume, and let us say for this customer, right, you want to get the rating of the customer, like a CIBIL report, assume. You want to say that before I calculate the discount, I want to just get, what is the CIBIL report of this customer, okay? So what you probably would do is, you'll say, okay, let's go to the implementation out here. So when I calculate the discount, right, so must be, you will create, let's say let's now again here, this. So let's say for this customer, we'll put one more property out here saying rating of the customer, kind of a CIBIL report or something, right? So that depending on that, we can, so rating. Now this rating is calculated, by going online, by hitting a web API and taking some data and doing something out here, right? So you go in the implementation and must be in the constructor, right? Let us say in the constructor, you will, let us say, I will just create an abstraction here, interface, I rating. This calculates the rating of a customer, get rating. So if you pass him an I customer, you will get that customer's rating to you, right? So now what you do out here is you say, okay, like I'm going to go and use this I rating out here. Okay, R. We'll come to this. I will come to the constructor injection. And you will just say that this dot rating, you will use this R dot get rating to get the rating of the current customer. Now look at this thing out here. Is accessible? Yes. So let's make all the interfaces public. Let's give it some exceptions. So now what you're doing out here, you have this rating object out here, you pass in the customer, you are getting the rating. This rating object here, you are not creating an instance of this. You're not storing somewhere here I rating. You're not storing it anywhere here. It's just coming in the constructor. You're just using it and then that's it. After that, you're not storing an instance. You're not doing anything, right? This is termed as association. Association means you have used that object, but you don't have any kind of instance stored inside it. There is a connection, but that connection is very thin. This is termed as association, right? The second one, let us say now you say, okay, there is a customer, right? And a customer, has, let us say, customer has addresses. Assume, customer has addresses, okay? So you'll say, okay, customer is there and you have an address. Address, okay, string address. So one customer will have multiple addresses, fine. So that means now this I address, you will say that your customer is having multiple addresses. So list of addresses. Now this one out here, right? Addresses is equal to, well, oh, this is an interface. Actually, I have to make it a property. Drop stuff addresses. Right. Now over here, if you see, there's a one-to-many relationship, right? Now in this case, what is happening is now this one here is nothing but your aggregation, right? Means what? Let us say now this is I customer, he is having addresses. Now let us say there is a supplier also. Assume that there are some suppliers who supply goods to you, right? So you create an interface of I supplier. Now this supplier also has list of addresses. What I'm trying to say is that this I addresses, right, or this addresses collection is not very special for customer. It can be used in supplier also. It can be used anywhere, right? This is termed as aggregation. In case of aggregation, what happens is that class or that interface can be shared between multiple classes. There is no tight connection. This customer does not own this I address. It can be used here. It can be used somewhere, for some other entity to define an address, right? This is termed as aggregation. In case of an aggregation, the lifetime of customer and addresses are not really tied up together. The lifetime of supplier and addresses are not tied up together. Or I will say the addresses is a common shared class. It can be used here. It can be used there. It can be used anywhere, right? So this is again one more important relationship which you have to understand when we are doing design pattern, because in design pattern you'll find all these things are coming in aggregation. And the last one is composition. So remember, our first one, association, which is just association like this. Second one, aggregation. I supplier does not own address. I customer also don't address. Address can be attached to anyone. Aggregation, the lifetime, or I will say there is no ownership over here. There is no ownership as such. Okay. But now let us say, let us talk about discount calculation here. Okay, assume we are doing discount calculation. Now, if you remember, our discount calculation, heavily depends upon the customer object. The customer has what amount, the customer is of what age, right? If you remember our requirement, it was very much, dependent on the customer object, right? So over here now, when I say calculate discount, calculate, I need the customer object. Without that, I can't. Okay, and must be even the customer object will need the discount for calculation, right? So now this is a very tight relationship. Here, the discount object, cannot be live, or it does not exist in reality without the customer object. This is a tight relationship. Here, the lifetime of customer and discount, both of them are same. Okay, like I cannot use this discount calculation, or I don't need to use the discount calculation for supplier as such, right? This is very specific to customer. This is called as a tight relationship. This is called as a composition relationship, right? So here what I'm saying is that, when let's say that if I want to use the discount calculation out here, right, I have to say I discount D and then return D dot calculate, I have to pass this customer object, or else this discount has no meaning as such, right? This is called as composition. So in composition, the lifetime of the objects are same. In aggregation, there is no, there is no ownership. That class can be shared to anyone. And in association, there is no instance sharing. It is just used in the constructor, just referred, get the value, and then it is gone, right? So aggregation, composition, and association. So guys, any questions still here? So guys, just to quickly revamp what we have done. We talked about, the mentality or the philosophy, where we said that you identify and you classify. That is nothing but the abstraction. Then we said, when the developers start writing the code, right, they do implementation. And when they do implementation, they have to use the public, private, protected, and ensure that they follow encapsulation so that, they follow abstraction, right? And by the virtue of polymorphism, where we say that the interface, can on runtime point towards this child and that child, right? We can achieve decoupling. And you can have a wrong abstraction if you don't understand the requirement. Within the family, there can be very, very thin families, right? And because of that, you can have a LISCO problem, right? And when we talk about relationships, one is you have inheritance, parent-child relationship. Another one is you have composition, or I will say this is a relationship, and this is a has a relationship, where we are saying we can have aggregation, we can have composition, and we can have association, right? So let me go to the questions here, and then very quickly we will. Okay, let us see. Let us look from the top, right? Okay. Okay, can we achieve abstraction by using a class? You can. Remember, abstraction is not abstract classes. Please understand. Again, I'm repeating. So can we use, yeah, you can use a class, but then what happens is once you start using a class, so let us say when you start using a class out here, the next step is you'll start writing the code. And then once you start writing the code, you'll write everything into it. So it is always good to, keep the abstraction separate and the encapsulation separate. Using abstract also, we can achieve it. Yes, you can. But so there's a good question out here. Let me put down the question. See, guys, it is important to understand the philosophy again. Because if you don't understand the philosophy, then again, the same questions will come. Using abstract also, can we go and do abstraction? Yes, you can. But then remember that in abstract classes, you can start writing code. Abstract classes are half defined. And once you start writing code, done. Once the developer starts writing code, he finishes it. Then everything goes into one class only, right? So I would suggest to keep these two things separate if you want to have a good architecture, right? Okay. The discount should be part of the customer class. So here it is. This is a good question here. And I will come to this, PK, that the question is that why isn't the discount a part of the customer, right? So we'll come to that. This question, I will just keep it for later. How can we identify abstractions from its requirements? Very good question here. So basically, remember, abstraction, the most of the time, I mean, like as a human developer, use this nouns and verbs funda. I will not say they don't use it. It happens very naturally. So whatever are the nouns, they become the entity. So like customer, supplier, doctors, patients, they all become the entity, and the actions like customer, pay bill, and all, those kind of things actually becomes a verb, right? So normally, if you say how to identify it, don't try to force yourself too much. Just, try to follow the abstraction. Just try to follow the end user. This is what the next thing is. The next thing is domain-driven development, where ask the end user. For example, in this case, right, if I had asked the end user saying that, do you think an inquiry customer is a customer? He would have said, no, inquiry customer is not a customer. So remember, your biggest architects are your end user. They will tell you exactly what they want and just architect as per them, right? So that's what I'm going to go and emphasize in domain-driven development tomorrow, right? It is very, very easy to go philosophically wrong. And once you go philosophically wrong, I don't want to tell you what happens in a project, right? And, because of the deadlines, let me agree to this. all software companies, bigger or small, or how much of a process they follow, right? They don't give you this cool mind to think abstractly. And when the start thinking goes wrong, right, everything goes wrong, right? So, okay. Yes, we are covering solid principles. Absolutely. There's a question here. Okay, let me talk. Okay. Please explain why properties in the interface. Usually I feel method names only. Okay, so there it is. Why should we have properties in the interface? Because properties are also having logic. See, there is a difference between a property and a variable. So when you say a property, let us say your property can have a logic, right? So that's why you can think about properties can have some action inside it, can have some code inside it. So that's why in interfaces you can have properties. Do you use UML diagram before coding? Very nice question from Alex here. Isn't it we should first draw the UML diagrams and then start coding? Absolutely, you should. And that's what we'll do later on when we do the UML diagrams. But at this moment, I didn't want to start with UML diagrams because I have to start teaching you UML, right? So I didn't want to go into that path. But yes, definitely, when you're actually doing your technical documentation, UML diagrams, class diagrams, I'm sorry, in UML class diagrams, then you have the activity diagrams, object diagrams. So some of these diagrams are very compulsory. We'll talk about that. We are covering solid principle. Is there any performance impact of polymorphism? There can be, but see, here, more than performance, you have to think about the good code as well, right? So if, let us say, by not using polymorphism, you can achieve some nanoseconds of performance, there is no point. So do not try to be too hard on performance first. First, try to create a good product out there, right? Now, in case if performance is the criteria, if somebody says, no, like performance is the biggest criteria, then frankly, let me tell you that object-oriented programming can be bad for you. Because in object-oriented programming, right, we follow inheritance, we follow polymorphism, we create so many instances, then you have the garbage collector running at the back. So must be that if you're looking at very high performance, then accordingly, you have to go ahead and tailor your architecture, right? But yes, but first I would suggest don't think about performance when you're thinking inheritance or polymorphism. Must be you will gain some nanoseconds, but you will lose the bigger part of it. Okay, there's a question here from Saloni that, okay, how to follow and decide architecture pattern like repository and clean architecture. I'll come to this later on, don't worry. In my syllabus down, if you see, right, I'm pretty much on all those patterns what you have seen out there. And also, patterns, which are revolving around microservices, and also patterns which are revolving around cloud. Okay, let's see from the top. Too many questions. Okay, let's see down. Okay, there's a question here. I'll come for the solid, right? Tomorrow we'll do solid. Can we have a private interface? You can have. Private, see, when you say a private interface, you can say them private, right? They are inside the namespace. That's what the private is. But the internal members cannot be private. This question here. In composition, customer can be without discount. One thing can live without. Okay, that's a good question. In composition, the customer can be without discount. Actually not. Because in this case, right, I would need, actually, I did not show it over there. Actually, this should, yes, there is a calculated discount out here, but this customer will use this I discount to do the calculation. So actually, this guy also need to have a reference. I did not put it out here. That's a good question out here. What the question was, fine. The discount is there where you're passing the customer, but like, the customer is not without a discount. Absolutely. For that exclusivity, right, to say that the customer will need a discount, right, you have to create I discount inside. You're right. Like this. So this is needed out here, actually. This I missed it out here. You're right. Okay, so there's a question here. Once I was asked, whether a generic class is type of polymorphism, the answer is no. Generic is not really polymorphism. Generic is during the compile time. See, again, guys, there is a compile time polymorphism, and there is a runtime polymorphism, and so on, right? Frankly, these are like technical things internal. If you ask me, polymorphism means the ability of an object to change and take different shapes. A customer can become a discounted customer, a customer can become an inquiry customer. So that's what the main goal of polymorphism is. Now I know that developers went one step ahead and said compile time and run time, and can generic be polymorphism. Then in that way, if I say then object O can also be polymorphism, I can say object O can point towards this, right? And then the same object can point towards a number. Why not? But see, we can't term everything as polymorphism. So I think the base, if you look at object-oriented programming when it started, the goal of polymorphism was decoupling. For example, at this moment, I'm teaching you, I'm a teacher, right? I'm trying to hide everything at the back, of my family problems or whatever is there, right? I'm a teacher. When I go and talk to my kids, I will not be talking about design patterns, right? I'll be a father. So polymorphism is the ability, where I can change myself and just talk to you things what are needed, and just talk to my kids what are needed. So here also, and that is the biggest thing of decoupling. That's the biggest essence of decoupling. The I customer can point towards normal customer. The I customer can point towards this customer. It can change. It can morph. So, if you want to technically ask what is generic, I would say no, it is not polymorphism, right? Even that static polymorphism, that compile time polymorphism, because of interviews, I tell to my students, yes, there is compile time polymorphism. But if you ask me as a developer, most of the time, I would be using this polymorphism. And many of the developers will agree to me that most of the time they use runtime polymorphism, right? So the answer is no. Like for me, generic is not polymorphism. Okay, let me see here. Okay, could not understand association. Okay, so here's a question. I could not understand association composition. Can you explain in more detail? Example, or it looks very similar. Well, so you can just go through the class again, Nishok. I can understand your concerns, right? And if you don't understand it still, you can just connect to me one-to-one, must be from Monday to Friday, and must be I can go more in detail. But the point is, in case of association, we don't have any instance references. In case of composition, both the classes, either they live together or they die together. The lifetime of both the object of the lifetime are together. They are exclusive to each other. And in case of aggregation, there is no exclusivity. Whether SRP and LISCO oppose each other? No, they don't oppose each other. So LISCO is very different. And SRP is single responsibility principle. So nothing as such. Remember, guys, all design patterns will cross each other somewhere. You will always find some synonym here and there, right? But definitely, at least the SRP and LISCO, they are two different concepts. They complement each other, but they are not same. So you think as one says together who change, but LISCO says that your interface should break. Yeah, interface should break, because you are put into a wrong family. In case of LISCO, it comes, where you don't know what to do with the method. You don't know what code to write. It's a very different situation. In case of SRP, your one class is getting loaded too much. So tomorrow, guys, we're going to go and talk about solid. So just hold your horses, we'll be going very in depth into solid. Yes, absolutely. Okay, guys. So I think any other questions? So I can see that we have 8 minutes out here, right? But let me not go into other things out here, because even if I start now, it would take more like 5-10 minutes, to complete, more 15 minutes to complete it, right? So very quickly, guys, I know this 1 hour which I started here can look very weird. Weird in the sense that it can put a lot of questions in your mind, right? But this is the main important part, I feel, the philosophy, the psychology of it, right? So first thing, I started talking about that humans understand complex system, basically by abstraction, by classification, by identifying entities and doing classification. After that, when developers start writing code to it, right, they have to just ensure that they respect that abstraction by using public, by using private, by using protected, right? When we are doing abstraction, right, we can do one big mistake called as LISCO. So if you have a wrong abstraction, you will put them into a wrong family, right? So it looks like a duck, it quacks like a duck, but it has batteries, right? Then we talked about polymorphism. Polymorphism is the most important part of decoupling, right? So you just see I customer at the back. You can have a normal customer. You can have this. You can have that. You just see Mr. Shiv as a teacher, but at the back, I'm a father. Must be, you know, I'm also doing some other activities, right? But you just see Shiv as a teacher, and this is a very important essence of decoupling. Remember, when we go one pattern after another pattern, you will find these word abstraction, encapsulation, polymorphism used left and right. Then we talked about relationships. In relationship, one is we have the easiest one, the parent-child relationship, and the most complex one, the has a relationship, you know, where we say aggregation, composition, and association, right? So that was the start today. And tomorrow, this is my plan. Tomorrow, my plan is first to start with solid. Let me move this at the top. What are solid principle? I know that I covered L today because L was needed here to make you understand the importance of wrong abstraction. But tomorrow I'll again go and cover the solid principle. And when we cover solid, right, we have to cover dependency injection and inversion of control. And when we cover dependency injection, we have to cover simple factory pattern at least, right? So tomorrow's day will go into solid principle, dependency injection, inversion of control, and simple factory pattern, not the factory pattern, right? So guys, thank you very much. Any other questions? Yes. Yes, the recordings will be available. Yes, absolutely. Right. Okay. Okay, there's one question. I'll take this. You know, I said at the start of the class, abstraction is not abstract classes. I don't know how I can emphasize this. And you know what? People ask questions in the interview like this. What is the difference between abstraction and abstract classes? What can we say, guys, right? Abstraction is thinking from the 30,000 feet level. Just from the 30,000 feet level, you want to just think that what are the important entities, what are the attributes. That's what is abstraction is. It is not abstract classes. Abstract classes are nothing but they are half defined parent class. Okay, thank you very much. Yes, thank you. Yes, I can see a lot of questions. Yes, go ahead with your question. Go ahead, Mohit, with your question, please. We can stop the recording now, but I can see that. Okay, please unmute Mohit. Must be we can take the liberty to unmute it. Please go ahead and stop the recording because at least the class has been done. Remember, we have 100 people in this room, so I will unmute only Mohit for now. Go ahead, yeah. Question support, if you can unmute Mr. Mohit Kumar. I think it is more than that we have got. Yeah.
Hello.
Go ahead, Mohit.